So here's a quick video on what we did today in remote lesson. Today is January 25th, remote Monday. So we talked about why we use synthetic division, polynomial division, and why synthetic division. So if they're asking you a question like, is it a factor? By all means, plug it in, plug the x value, and then go from there. But if they're asking you what the answer to the division will be, you should be using synthetic division than long division because it's much easier. So we did this example over here, x to the fourth minus 2x to the third plus 3x plus 1 divided by x minus 3. So one of the things that let's remember, x minus 3, it says for me to use the synthetic division, just over here, I have the x minus 3 equals 0, x equals 3. So I use 3 right over here. And if I have a missing term, I have to replace that with a 0 to be able to use the synthetic division methods. So at times you might want to use the synthetic division even if it's a factor or not question, because it might be a really weird big polynomial with a lot of terms, just not like these basic ones sort of, and it might get huge numbers. I don't know. I just want to make sure that standardized testing is a different situation. So in the standardized testing, they might not even ask you a question that actually you need synthetic division for. So, but it's one of those things, it's really good to know just for the fact that it will give you the answer to your division answer. So let's talk about how we do that, okay? So our polynomial is x to the fourth minus 2x to the third plus 3x plus 1 divided by x minus 3. Is it a factor or not? Whatever. Well, once I put my 3 over here, I make this L, and then as in pink over here, you see that I wrote all the coefficients, including my constants, in my polynomial. And then the first step is I bring down this first number down, and then I multiply it with the 3. Whatever the answer is, I write it over here, and then I add. The answer is 1, multiply again, write it over here, add again, and so on. The last number I have is the remainder. If this is 0, well, if this is 0, it's a factor. If it's not a 0, it is not a factor. So once I get these numbers over here, the best advantage of the synthetic division is I can right away write the polynomial answer to my division, which, because this is starting with a fourth, and I'm dividing with a first degree, fourth degree divided by first degree is going to be a third degree. So x to the third plus x squared plus 3x plus 12 with a remainder of 37 would be my answer to this division. So hope that helps with these notes together. And that's it from me for the polynomial division, synthetic division, why you use synthetic division, when you should use synthetic division, why it comes handy. And this is the second portion of today's January 25th remote Monday lesson, which we did end behaviors of the polynomials. So the end behavior, we said that where these arrows go to, as x approaches positive infinity or x approaches negative infinity, how can I predict these things? So there is a method, we said, and the method is depending on the polynomial's degree being odd or even, and the leading coefficient being positive or negative. So let's go and try to explain why I want you guys to relate these to linear equation and the quadratic equations for easier understanding and getting to the answer portion of it, I guess. Because I know that linear, right, the linear equations are first degree equations. Linear first degree odd. So x to the third, x to the fifth, x to the 13, x to the 11, and so on, etc. All of these are odd. So they will behave the same way as linear. Okay? So, linear, if it's this way, it means positive, and if it's this way, it's negative. Well, let's the same exact way if, let's say, x to the third kind of a function. Well, it's positive and it's odd. So it's going to start from here and it's going to make something like this. And the cool thing about this is that because this is 3 minus 1 is how many vertexes equal to vertex or vertice, I believe. I'm not sure about the plural name. Don't hold me responsible for English and the grammar parts. Anyways, so see, that's going to be 2. Let's say I have negative x to the third. Well, let's also do this. This kind of resembles a positive slope. See, if I would have a negative x to the third, I would have something like this. Because this is going to resemble a negative slope. And again, because it's x to the third, I have 2 max or minimum. Max, minimum. So that's why I relate it to the odd and the linear, and it works for me. What about the even? So that's quadratic. I know it's x squared or negative x squared. Well, x squared gives me a graph that both of my ends go upwards. And negative x squared gives me a graph where both of my goes downwards. So I'm going to relate anything that has negative degree. So that can be x to the 4th, x to the 8th, x to the 12th, so on. I don't know. It can be anything. So let's try what it would look like for x to the 4th. Now remember, minus 1 is the number of minimums and maximums that I'm going to have. So 4th degree should give me, and let's put it as like positive x to the 4th. Because it's positive, it should point upwards, just like in quadratic. But I should have 3 maximum and minimum or vertexes. So I should have something like this. Obviously, I'm making these graphs kind of obvious, as symmetric as possible, so it's easier to see. And if I would have, let's say, a negative x to the, let's do a 6th. So I'm going to have 5 of these. Interesting. Let's see that. So negative, I'm going to start from here. So that's 1, 2, 3, 4, 5. Did I do right? 1, 2, 3, 4, and 5. So yeah, I actually did it right. And 1, 2, 3, 4, and 5. So it looks like mountains. Anyways, so I hope it makes sense why we are talking about the linear and the quadratic. I'm relating it to those things. And the wording that we use is as x, and this means approaches to negative or positive infinity, my function approaches negative or positive infinity. So that's about it. So this is January 25th, remote Monday. Alrighty.